Hey everybody, in this video today we're going to be looking at multiplication methods for both whole numbers, integers and decimals. The reason why I'm looking at this is because there's a number of times in class when there will be some students or myself, if I'm up on the board, that needs to do a quick multiplication. And it's always too tempting to reach for your calculator, type it into your calculator, and then go from there. But really, in order to make sure that you've got fluency within your number work as well as some of your algebra work, being able to do some of these quick multiplications using some form of written method to one side can be really helpful, especially for some of the kind of ones that you can do in your head. So what I'm going to do for this video is to show you a couple of methods for how I would look to do some quick multiplications, either with the aid of something written down to one side or for, doing things purely in my head, and I'll show you how I keep track of them as well. Okay, so let's have a look over. Let's get started. So in the screen here, I've got a series of different multiplications, okay? We've got just some normal timesing by a single digit. So I've got like 17 times by a single digit, 148 times by a single digit. Moving on to timesing by 2 digits, a decimal times 2 digits, and then lots of decimals times together. So I'm going to go through the full scope of what I would do, how I would do it, and so that you can see that as well. So starting with the thing right at the very top, okay, this one right over here. For something like this, I wouldn't actually personally use a written method. I would look to chunk it up into two different things, because to do 17 times by 9 would be the same as me doing 10 times 9 plus 7 times 9. Okay, and if you wanted to stick some brackets around that to make it a little bit more clear, then you could do. That's what I'm thinking when I do a calculation like that. So 10 times 9 gives me 90. 7 9s are 63. Add the two things together, we get 100 and 153. Okay. Nice, quick multiplication. Knowing your times tables does help, okay? But for something like this, where you have a number times a single digit, just chunking it up into like 100 times the unit, a tens times the unit, and units times the unit can make it a lot more easy to deal with. And that's a method that I would use with my students sometimes, just to kind of go, if they say, "Sir, what's 12 times 9? I go, "What's 10 times 9? What's 2 times 9? Right, add them together." Okay, that's what I would be looking to do. So we could step it up a notch and have something like 34 times by 7, and look to do that in our head instead. Okay. Now, you could pause the video right here, have a go at it in your head without using a calculator. Now, splitting it up, we'd have 30 times by 7 plus 4 times 7. Okay, the 30 from the 30, 4 from the 4, both timesing by 7. 30 times 7, well, 3 times 7 is 21, so 210. 4 7s are 28. 238. And it also works with 3-digit numbers as well. Okay, so taking the one that we've got up here for an example, I can split it up into 100 times by 6, 40 times by 6, and 8 times by 6. It's essentially what we're doing in long multiplication or column multiplication, just written out slightly differently. Okay, so 100 times by 6 is 600. 40 times by 6, well, 6 4s are 24, add the 0, 240. 8 sixes are 48. 8, 8, 8. Okay? So even doing multiplications like that, if we've got like just a number of digits, we could even go into the thousands if we wanted to, times by a single digit, I would just split it up in that way, and that's what I would be doing in my head, okay? When it comes to doing things with a couple of digits, though, that becomes a little bit harder to track, okay? So I normally look to resort to using a particular method at this point, okay? Now, having looked at all the different multiplication methods that I have done since I've been teaching, the one that I think that actually makes the most sense in terms of transplanting from integers to decimals and things like that is what we call Napier's bones, okay? And Napier's bones is set up in a grid-like way, okay, where I would have my grid set up like this, 148 times by 16, okay? And we divide each square into a diagonal so that we can split up our answer into patterns of tens and units. And then we're going to look at what digits we get left over and add up going diagonally, okay? So that's the setup. We need to fill in the boxes. So 8 times 1 would be 0 tens, 8 units. 8 times 6 is 48. So that's 4 and 8, 48. 4 times 1 is 0 tens, 4 units. 1 times 1 is 0 tens, 1 unit. 4 sixes are 24, that's 2 tens, 4 units. 1 6 is 0 tens and 6 units. So now I want to add up going along each diagonal, okay? And when I do that, I'm going to get each of the digits that go into the answer. So on my first diagonal, I just end up with an 8. Okay. For my next diagonal, I've got 8 add 4 add 4. Well, 8 add 4 is 12. Add 4 is 16. Okay. Now, because this splits up into 16, I've got a 6, and then the next column over gets an additional 1. It's like you're carrying your tens over. 4 plus 2 is 6, plus 6 is 12, plus 1 is 13. The 3 goes down in this column, the 1 travels over into the next diagonal, because it's like I'm carrying my 10 over again. And then I have 0 plus 1 plus 0 plus 1, which is just 2. Okay? No decimal points, so the number that I end up with is 2,368. Okay? And if you wanted to, you could take a calculator, check that out, just to make sure, but sure thing, we get 2,368. Don't take my word for it, check it out. Now, that's not to say that that's the only method of doing things. I will see students using column method as the kind of preferred way of teaching multiplication in primary school. I will see students doing grid multiplication as well, because that links in nicely with doing algebraic expansions as well. But for purely dealing with numbers, I would say that this is my kind of preferred method. And when we go into decimals, this will definitely show you why. Okay, so 27.8 times 36. I'm never going to look to do something like that in my head. Okay, I'm gonna do that on paper 10 times out of 10. Okay, so I set out my grid. I'm gonna have 200 or we're going to write 278 for the 27.8, and then 36 going down the side. I'm just going to split this up into my grid. A little bit wonky, but it doesn't matter. What matters is we've got all of the bits there. Put in my diagonals. Okay, and again, it's a bit wonky, but it doesn't matter. Here we go. So I'm timesing these two things together. My decimal point, just for reference, is right there. Okay, between the 7 and the 8. I can't wiggle it in because of how things are. Okay, so what did we do? Well, we kind of looked at doing the multiplications for each of the individual boxes. Okay, so let's do that. I've got 8 times by 3, which is 24. 7 times by 3, which is 21. 2 times 3, which is 6. So 6 would be 0 tens, 6 units. 8 times 6, which is 48. 7 times by 6, which is 42. 2 times 6, which is 12. Okay, and you can see how knowing your times tables actually makes things really snappy with that. Okay, and just as we did before, we add up going along each of the diagonals. Okay, so first diagonal is just 8. Second diagonal, 4 add 4 is 8, add 2 is 10. That's a 0, and 1 carries over to the next diagonal. 2 add 1 is 3, add 4 is 7, 8, 9, 10 again, so 0, 1 goes over into the next diagonal. 2 add 6 is 8, add 1 is 9, add 1 is 10. 0 goes down, 1 carries over into the next diagonal. 0 plus 1 is 1. Okay, now here we've got the decimal point to worry about. Okay, and for my decimal point here, what I need to look at is where would the decimal points kind of match up if we were to make them meet. Now 36 does not have a decimal point. Okay, it doesn't have one at all, so all that decimal point does is drop down just in there. Okay, so I'm going to have an answer which is 1000.8. Relatively nice round answer. And again, just to double check, make sure that we haven't done anything wrong. And it's good to double check things when you're starting things out, just to make sure that you are doing things right. We do indeed get 1000.8. Okay. So the thing now is we've done a question which has one decimal place. What if we've got many decimal places? Well, I would still use my Napier's bones method. Okay, this is the proper name for this method. Okay, so we're going to get our grid ready. Okay, we're going to do 3.45 times 7.4. Draw our grids in and try and make it that your decimal points go through on those lines. It really makes it easier if you've got squared paper or something like that. Okay, and there we go. There's our diagonals ready to go. Okay, you might want to pause the video here, try it out for yourself. Again, see how it goes now that we've gone through a couple of examples, and see if we end up with the same answer at the end. So here we go. We're timesing these two things. So 5 times 7 is 35. 5 times 4 is 20. 4 times 7 is 28. 3 times 7, 21. 4 times 4 is 16. 3 times 4 is 12. Okay, I've not done any of those boxes in any particular order. So long as we get all of those numbers in those positions within those boxes, we're good. And what did we do after that? Have a look. We add up going along each of the diagonals. So 0. Fair enough. 5 add 2 add 6. Well, 5 add 2 is 7. 7 add 6 is 13. 3 add 8 is 11. 12. 13, 14, 15. Remember, if we get a 10 from adding things up, the tens column goes into the next diagonal. 2, add 1, add 1, add 1. It's 5. Okay, I'm kind of running out of room here. Actually, let me rearrange that. So 2 add 1 is 5. And then 2 left at the very end, okay? Now, our decimal point, okay, our decimal point here, we're going to look to see where they would match up. So this decimal point would come down, this decimal point would come across, and they would meet here, okay? Which means that the decimal point slides in between those two digits, or between these two diagonal columns. Okay, so the answer that I'm going to get when I put everything in order is going to be 25.530. Now, the 0 at the end doesn't matter. We can lose that. So 25.53. Okay, that 0 at the end is not significant. We don't need to count it. So we're just left with 25.53. Okay, so that's how I go about my multiplication methods, okay? And that's how I would recommend that students go about their multiplication as well, okay? Now, I did say that there are other ways of doing these. Yes, there are, but you need to be really careful when extending into decimals. Column method, you've got to make sure that your numbers line up properly, okay? With grid method, if you're using that and you're using decimals, you've got to make sure that you use the right number of decimal places when you set out your grid. Okay? I think that using Napier's bones like this is by far the easiest way to do any form of multiplication, whether you're talking about like just whole numbers or decimal numbers. Okay? That's my personal opinion. Okay, I would look to do these, okay? But if I'm just timesing by a single digit, like up here in this top box, I would split things up, do them in my head, and then perhaps do a quick addition on the side later, okay? This is what I would do. Okay, other teachers might teach it differently. This is what I personally would recommend if you're looking to find those number-based multiplication techniques. Okay, that's going to be it for this video. If you see something in this video and you want to email me with a question, if you're one of my students, fine, I will answer that email back. If you want to try out some of the quizzes that we've set on Heggerty, or the extra or the alternate worksheets, try some of those out now. Use some of these techniques to help you, okay? And see how they go. All right, I'm going to leave it there for this video. Hopefully see you in the next one. Bye-bye.